An electron moving at a velocity of 6.7 times 10 to the power of 6 meters per second east enters a magnetic field with a magnitude of 2.3 Tesla directed at an angle of 47 degrees to the direction of motion and upward in a vertical plane. What are the magnitude and direction of the magnetic force on the electron? Part B, what is the electron's acceleration? If its mass is 9.11 times 10 to the power of negative 31 kilograms. And part C, what would the acceleration be if the charged particle were a proton of mass 1.67 times 10 to the power of negative 27 kilograms? Let's start with the part A. We need to find out the magnitude and direction of magnetic force. F equals to B times V times Q times sine theta. F is the magnetic force in terms of Newton, B is magnetic field strength in terms of Tesla, V is velocity of charged particle in terms of meters per second, Q is the charge of the particle or particles in terms of Coulomb, and sine theta, theta is the angle between magnetic field and velocity direction. So let's find out F. Magnetic field strength is 2.3 Tesla, velocity is 6.7 times 10 to the power of 6, Q is 1.6 times 10 to the power of negative 19, and sine 47. So that make it as so the answer is 1.8 times 10 to the power of negative 12 Newton. Now we need to find out the direction as well. In order to find out the direction of magnetic field force, we need to use the right hand rule. Thumb is showing the velocity direction. 4 fingers showing the magnetic field direction, and then the palm is showing the magnetic force direction if we are dealing with a positive charge. If we are dealing with a negative charge, we just make it the opposite way. So let's do this example. Velocity is going east, and magnetic field is in the vertical plane upward. It's gonna be something like that. So if we use the right hand rule, and if we are dealing with the positive charge, that's going, the palm is going this way, down. But we are dealing with a negative charge, we are dealing with electron in this case, so we need to make it opposite. So force is going to be toward north. Or we have another option to use our left hand instead of right hand. If we are dealing with negative charge, we can use our right hand and make it opposite way, the answer, or we can use the left hand right from the beginning. Now let's do the part B. Part B, it says, what is the electron's acceleration if its mass is 9.11 times 10 to the power of negative 31. So magnetic force equals to ma. A equals to magnetic force divided by mass. Magnetic force we calculated 1.8 times 10 to the power of negative 12, and mass in terms of kilograms is 1911 times 10 to the power of negative 31. That will be almost 2 times 10 to the power of 18 meter per second squared. That's the unit for acceleration. Part C, it says, what would the acceleration be if the charged particle were a proton of mass 1.67 times 10 to the power of negative 27? So in this case, we need to find out F again. B is 2.3, V is 6.7 times 10 to the power of 6, Q is 1.6 times 10 to the power of negative 19, sine 2.47, because we need to use the charge of the electron, charge of the proton, which will be 1.8 times 10 to the power of negative 12 Newton. Same as before. Why same as before? Because the magnitude of electron and magnitude of proton are exactly the same thing, but they have different sign. One of them is positive, the other one is negative. The only difference here is mass is different. Mass of proton is much larger than mass of electron. So A equals to 1.8 times 10 to the power of negative 12 divided by M, 1.67 times 10 to the power of negative 27. That is going to give me 1.1 times 10 to the power of 15 meter per second squared. This is the acceleration of proton.